We're going to look at the graphs of cube root functions, and a cube root function is very similar to a square root, only it has an index of 3. And remember, index is that little tiny number inside the like square root symbol or the radical symbol. So this right here is a 3. That's our index. So we know that we're dealing with a cube root function. The parent function for the cube root functions is just the basic one, y equals the cube root of x. And unlike square root functions where you can only take the square root of a positive, we know that you can take the cube root of a negative number. So the domain and range are both all real numbers. Because if you look at the graph, it goes on in both x directions and it goes on in both y directions. I mean, it goes pretty slowly down the y's, but it's all real numbers because it would extend. The graph of the cube root of x, or our parent function, increases across the entire domain. So as you go further and further towards the positive x's, then you get further and further positive. Your y values are constantly going to be going up. Sometimes they're going up slowly, sometimes they go up quickly like it does here, but they're always increasing. You're always getting a larger y value. And you can transform these like we did all of our other graphs. You can flip it, you can shift it, and that's what we're going to look at as we go through this lesson. Example 1 wants us to graph h of x equals the cube root of x minus 4 and compare that to the parent function cube root of x. Now you might already know it's going to be shifted down 4 because of the way the equation is written. So you could have answered that question if you wanted to. You'll also see that in the graph. All right, so what I want you to do is just pause the video right now and can you just transfer this parent function graph on here? And then press play when you are ready. So what you want to do is you can either take this and just bring it down 4, or you can make a table. Table is going to be the safest way if you are really want to make sure that you get the right answer. And remember, if you get to pick the numbers and pick numbers that are friendly. So I'm going to pick perfect cubes. I'm going to pick -8, -1, 0, 1, and 8 because all of those are perfect cubes. 1 cubed, 2 cubed, 3 cubed, 4 cubed, etc. So the cube root of -8 is -2. -2 minus 4 is -6. The cube root of -1 is -1. Minus 4 is -5. Cube root of 0 is 0. Minus 4 is -4. Cube root of 1 is 1. Minus 4 is -3. And cube root of 8 is 2. Minus 4 is -2. So you see in the graph, you see it's always increasing, which is what we talked about before. So now I'm going to plot it. Oh, I can't fit -8. Alright, well, I'll just fake it. -1, -5, 0, -4. That's -3. It's really important when you do this that you remember that you're graphing a cube root function and not a linear. So don't make it a line. And you can see from the graph, it just shifted down 4. So h of x got shifted 4 down from f of x. Now you see why I said making a table is going to be the safest bet, because this is a little more complicated. You might already kind of know what the shifting, we can see by the negative, it's definitely going to flip down, but like how are you really supposed to know what that's going to look like? You guys are all noobs. So let's make a table. And just like with our square root table, we want to pick numbers that are going to give me friendly integers. So I want to think of friendly cubes. perfect cubes. So over on the side, I'm going to make a list of perfect cubes. So 1 cubed is 1. 2 cubed is 4. No, 2 cubed is 8. 3 cubed is 3 times 3, that's 27. 4 cubed is 64. Hopefully I don't have to go that high. Okay, so I need to think about what numbers are going to work. Oh, and obviously 0, right? Just like with our square roots, 0 is a friendly cube. Now, if you think about it, I can really just do these first 3 because I can also then do the negatives. So, what number do I need to make -8? What number plus 2 is -8? Well, that's -10. I won't make you type it in. What number plus 2 is -1, right? So I'm trying to get -8, then I'm trying to get -1, then I'm trying to get 0, then I'll try and get 1 and 8. So what number plus 2 is -1? Well, that's obvious, sorry. That's going to be -3. What number plus 2 is 0? That's -2. What number plus 2 is 1? What number plus 2 is 8? Okay, so I don't need these numbers anymore. They're probably more of a distraction than anything else. And now I'm just going to plug those in. So why don't you pause the video, plug those numbers in. All right, that's what I got. If you didn't get that, pause the video, recalculate, and see if you can figure out where your mistake is. Let's go and let's graph. I do want to fit all my numbers in here, so I'm going to go by 2s. I'm not going to really show all the numbers. I'm just going to show the pattern, and then you, my reader, will have to figure it out. So let's plot our points. So that's -10, 2. That's -3, 1. -2, 0. -1, -1. And 6, -2. Again, when you go to graph this, make sure that you don't make it a line, make it a curve, and that's our graph. So I won't make you regraph the radical x. I'm going to pop it up on the screen. If you want to regraph it, you can. You can see that compared to the parent function, it flipped. And because of this +2 inside the radical sign, it got shifted to the left. G of x got flipped and shifted 2 to the left. All right, so in example 3, there's a whole lot going on. There's a stretch, there's a shift, whoa. I would like you to pause the video, see if you can figure out what numbers to use in the table, and then graph it. Now, if you get stuck on what numbers to use in the table, I'll pop those up in a second, and then you can keep working. But I want you to do as much as you can on your own. All right, I got -5, 2, 3, 4, and 11 for my chart because I was trying to get perfect cubes. I'm going to scribble these perfect cubes out so they don't distract me. And now continue on. There's my graph. When I got my table, I was like, wow, that looks weird because it feels linear, but because it's not an equal scale on the x-axis, it doesn't turn into a line. So there's the graph, and now we have to describe the transformations. Inside the radical sign, it got shifted 3 to the right. Outside the radical sign, it got shifted 4 up. And because we've got this coefficient, it made it stretch. So that's all I'm going to write down. All right, as we look at example 4, it wants you to talk about the average rate of change over a certain interval. I don't think that's really that important for understanding the idea of a cube root function, which is like where we all are right now at the beginner level. So we're going to skip example 4. And let's look at example 5. That has to do with a graphing calculator. So we'll hold off on that. If you have any questions, write them down and ask me when you talk to me next.